Okay, so we are looking at vertical motion. That is an object that is falling or an object that has been thrown upwards. So there are things I want you to take note of before we get into the calculations. Okay, so when we're looking at vertical motion, you have to take note of these points. Okay, so when an object is thrown up, it is decelerating. Okay, so when an object is thrown upwards, it is decelerating. Okay, so whenever we are talking about vertical motion, okay, so acceleration will be equal to g, which is gravitational acceleration. Okay, usually at O level, the actual value of g is something like 9.81 meters per square second. Okay, but usually at O level we round this. You round this. Okay, so g will be basically 10 meters per square second. Okay, at O level. Okay, so when an object is going upwards, it is decelerating, which means g will be equal to negative 10 meters per square second. Okay, g will be equal to negative 10 meters per square second. Okay, whenever an object is going upwards, g is equal to negative 10 meters per square second. You have to always remember that. Okay, so the second point I want you to know before we get into the calculations is that when an object is falling, it is accelerating, which means g is positive. Okay, when an object is falling, g is positive. Okay, so this is going upwards, g is equal to negative, and going upwards. When an object is now falling, okay, so g is now positive, it's now 10 meters per square second. Okay, so we all know that A stands for acceleration, G stands for gravitational acceleration. I'm not going to talk much of the variables right now. We're just going to get into the calculations. Okay, now the third statement I want you to take note of, the third thing I want you to take note of is that gravitational acceleration is constant. Okay, gravitational acceleration doesn't change. When a question tells you to use 9.82 meters per square second, you use that. When a question tells you to use 10 meters per square second, you use that. Gravitational acceleration is constant. It doesn't change. Okay? So, okay, these are the equations of motion. Okay, these are the equations we're going to be using to tackle these questions. Okay, so just a brief recap to those who might not know this. So, X stands for displacement, A acceleration, V final velocity, U initial velocity, T time. Okay, so obviously at this point when you're O level, you already know that displacement will always be in meters, acceleration will be meters per second, final velocity is meters per second, initial velocity meters per second. Okay, so we're not going to talk much of this. Okay, so we are concerned about these equations. We want to use them to tackle problems right now. Okay, so I'm just going to go briefly explain these equations, then we start solving questions. Okay, so the first equation. So these equations can work both in horizontal motion, linear motion in a horizontal fashion, but when it's now vertical motion we are going to be replacing A with G. Okay, A acceleration, we are going to replace this acceleration with G. What is G? G is the gravitational acceleration, and which is 10 meters per second, per square second. Okay, so whenever we're talking about vertical motion, A is going to be replaced with G. They are both accelerations, but when we are talking about vertical motion, G is constant. Acceleration will be constant throughout. Okay, so we're going to be using G. Okay, the first equation, just a brief recap, but I know you already know about this. So X is equal to V plus U over T. X displacement is equal to average velocity times time. Average velocity is obviously equal to V, which is the final velocity, plus initial velocity over 2. This is the average velocity times the time. Okay, so this is a general equation. Everyone knows this, that distance is equal to speed times time. Okay, in this case, we're just saying average speed times time, average velocity times time t. So x displacement is equal to v plus u over t, v plus u over 2 times t. Okay, the second equation, A, acceleration is equal to final velocity minus initial velocity over time t. Okay, so that's the acceleration. Whenever you want to find acceleration, you use that equation. So we also have this equation, which is an interesting one, which is final velocity squared is equal to initial velocity squared plus 2ax. A acceleration, then x displacement. But you have to take note now. We said that a, we are going to be replacing a with g. Then x is equal to ut plus half at squared. Okay, displacement is equal to final initial velocity times time plus half of acceleration times time squared. Okay, okay. Now we want to get into the questions now. So keep these, to those who are writing notes, keep these equations close to you. Okay, keep these equations close to you. Then let's go solve equations. Let's go solve equations. Okay, these are the questions we're going to be tackling. Okay, so to those who are a bit ambitious or eager to learn, you can pause the video and try these equations by yourself. Then after I'm done calculating, you can now verify your answers. Okay, it's always good to put a little effort. Okay. Okay, let's start. We're going to be start. I don't know if you're seeing these questions clearly, but I hope you are. Okay, so the first question is saying a small solid sphere falls freely from rest in air, okay, with acceleration of what? Of 10 meters per square second. Okay, so I want you to take note of this. Whenever a physics question says from rest, or from rest means that it just means that the object is starting at zero or ending at zero. Whenever an object is on rest, it means it's not moving. It is at a stop. Okay. I was saying whenever an object is said to be at rest, it means it is not moving. Velocity is zero. Acceleration is zero. Okay, so let me read the question again and we start calculating. A small solid sphere flows freely from rest. Okay, freely from rest, which means what? Our initial velocity is equal to 0 meters per second. We are now drawing now. Then with an acceleration of, which means a, I told you for all levels you usually use 10 meters per square second. All right, that's the acceleration. Okay, so the question now is, how far does it fall in 5 seconds? Okay, how far does it fall in 5 seconds? Okay, so let's take note of our equations, okay, and see what we can use. Okay, so you must know what we are looking for here. We are looking for displacement. Okay, how far is displacement? Okay, so obviously we're going to use the first equation. Okay, so we're going to say x is equal to v plus u over 2 times t. Okay, so we know that how far does it fall in 5 seconds? We know that our v, we know that u is equal to 0, right? So we have u, which is equal to 0, is equal to 10, but we don't have v now. We don't have v. So ultimately we're going to be looking for another equation that we can use that is very applicable to our case. Okay, so which means this equation is at a stop. Stop this equation. We go look for another one. Okay, so this fourth equation, I want you to take note of this. This fourth equation is saying that x displacement is equal to ut plus half at squared. At squared. So this is our equation now. There are no unknown variables in the equation. Okay, so we are now substituting the variables with their values. Okay, so x, take note of the question here. Let me bring the question again. Take note of the question. The question is saying, how far does it fall in 5 seconds? Okay, so we know t is equal to 5 seconds. Okay, so we are now substituting the values now. So we said that the object is starting from rest. When you have an object starting from rest, which means u is equal to 0. So u is 0 time 5 seconds, right? 5 seconds plus half of what? Half of the acceleration. The acceleration is 10 meters per square second, as the question has mentioned. You can see that the space falls freely from rest in air with an acceleration of 10 meters per square second. How far does it fall in 5 seconds? Okay, so we are now finishing. X is equal to 0 times 5 ut. U is equal to 0, t is equal to 5, plus half of acceleration, which is equal to 10. T squared, which is 5 seconds squared. Okay, so 0 times 5 here, this is 0. So which means x displacement is equal to half of 10 times 5 squared. Okay, we know that 5 squared is equal to 25. So x is equal to half of 10 times 25. So 2 into 10, which is 5. 5 times 25, which is 25 times 5 here. Times 5, we are seeing that 5 here carried to 10 to 125. So we are seeing that x is equal to 125. But x's displacement is measured in what? In meters. So 125 meters. So that's your answer for question 1. That's your answer for question 1. So I'm going to need you to stay with me here. Okay? Concentrate. Okay, so I'm going to be moving a bit fast, so I'm going to need you to stay with me. So we are now moving to the second question. This question we have tackled it. Okay, to those who were trying it out, congratulations if you got it correct. Okay, so we are now on the second question, which is question 4 on the paper. So I'm now reading the question now. So a projectile is fired vertically upwards and reaches a height of 7.4 meters. 78.4 meters. 78.4 meters, okay. Find the initial velocity of the projection. Okay. Find the initial velocity of the projection. Okay, we now go back to our equations again. Okay, I'll read the question again. So, a projectile is fired vertically upwards and reaches a height of 78.4 meters. Find the initial velocity of the projection. Okay, so let's attempt by using this equation. So we know that v squared is equal to u squared plus 2ax. Okay, we know this is the third equation of motion. Okay, so let's look at what we have according to the question. We have according to the question, where did I put the question? So according to the question, we have x displacement, which is 78.4 meters. So according to the question, we can see that we have x, which means x is equal to 78.4 meters. Okay, and acceleration, we know that acceleration is what? 10 meters per square second. Okay, so we have acceleration, and we also have the final velocity. The final velocity at the highest point the projectile reaches. Let's say you throw a stone in the air, vertically in the air. So as the stone goes up, right, the highest point it reaches, at the highest point, the final velocity at the highest point is going to be equal to 0. Why? Because the object was decelerating as it was moving upward. So I've talked about this and I'll say it again. When an object is going upwards, it's losing speed. That's why it will go to a rest position and start falling again. When it's now falling, it's now gaining in speed. Okay, so it's now acceleration. So I told you that when an object is going up, its acceleration is going to be a negative, right? It's decelerating. When it's going down, the acceleration is going to be a positive because it's gaining in acceleration, it's gaining in velocity again. It's gaining in velocity. When it's going up, it's losing velocity. When it's going down, it's gaining in velocity. Okay, so at the highest point the object will reach, I said what? The final velocity at the highest point is equal to 0. The highest point is equal to 0. So that's what we have. So if we plug our values into our equation, we can see that, okay, there's something you need to do here on this equation. Because according to the question, the question is saying, find the initial velocity of projection. Okay, so the initial velocity is u. So we are going to first make u the subject of the formula. Okay, so we can see this whole term, which is a positive, will go to this side of the equation and be a negative. So we will see that v squared minus 2as. Just hope this concept of making a variable the subject of the formula is not new to you. If it's new to you, maybe this video is not for you. Then v squared is equal to v squared minus 2as is equal to u squared. Is equal to u squared. Okay, so I think at this point everyone is on board. Okay, so we are now plugging in our values. So v squared is equal to this term. Okay, so we are now substituting, we are now putting in the values now. So v is equal to 0, so 0 squared minus 2 a is equal to 10 meters per second, a is equal to 10. And then x displacement was mentioned in the question and is you can see that it's 78.4 meters. Okay, 78.4 meters, and it is equal to u squared. Is equal to u squared. Okay, 0 squared is equal to 0. So we are saying that negative. Okay. Remember what we mentioned earlier, that we are going to replace a with g, and this okay, let me replace a with g there. And I want you to take note of something. The object has been thrown vertically upwards. So whenever an object has been thrown vertically upwards, I've said this before, acceleration is going to be g. G is going to be negative g, right? So since it has been thrown vertically upwards, g is going to be a negative. Okay, so this negative times this negative is going to lead to a positive, right? Then 2 times 10 is equal to 20. So we're going to end up with 20 times 78.4 is equal to u squared. Okay, so I was just taking my phone as a calculator. So we are now saying 20 times 78.4. 78.4. 20 times 78.4, which is equal to 1,568. So 1,568 is equal to u squared. Okay, we apply the square root sign to remove u, to remove that squared on u, that power 2 on u. So obviously u squared, the square root of u squared is going to be u, then the square root of 568, right? The square root of 568. Okay, so when we plug in the value now, so the square root of 1,568, we can see that it's equal to 39.6 if we round it to the nearest decimal place. So the initial velocity, we know that the velocity is meters per second. Okay, so therefore the initial velocity is equal to 39.6 meters per second. Then you're done. So let's move on to the next question now. Okay, which is number 5 in this, which is number 5 on paper. Okay, so a stone is thrown vertically upwards with an initial velocity of 29.4 meters per second from the top of a tower which is 34.3 meters high. Okay, so if you're not seeing the question clearly, you can write it down as I'm reading it out loud. Okay, so I will start reading the question again. A stone is thrown vertically upwards with initial velocity of 29.4 meters per second. So let's start writing our variables down. So we know that we've been told that u initial velocity is 29.4 meters per second. That's what we've been told so far, right? And from the top of a tower which is 34.3 meters high. Okay, this variable will leave it like that for the moment. So let's hear what the first question wants us to do. Okay, so time taken to reach max height. Okay, find time taken to reach maximum height. So we don't know how high the stone will go. We've not been told that. So we've only been given the first variable, which is initial velocity, which is 29.4 meters per second. Okay, so let's start looking at the equations now and start figuring out what we can use and what the question is demanding from us. So the question is demanding time taken to reach maximum height. So we are looking for time. Okay, we are looking for time. Okay, but we don't have the displacement. We don't know how far the stone went. Okay, so according to the first equation, we see that there is x, which is displacement, in the equation, of which we don't have displacement. We have not been told how high the stone went. So this equation, we're going to leave it for the moment. Then the second equation, it has a, the acceleration, which is always constant. Okay, so let's write that variable down, which our acceleration is equal to g, which is constant, which is what? Which is 10 meters per square second. So the question basically is demanding what? The question is saying find the time taken to reach maximum height. Okay, so obviously we're going to use this equation. Why? Because there is no x in it. There is no displacement. And because we have not been given displacement. So this equation is saying that A is equal to V minus U over T. But we're not looking for A now. We are looking for T. The question is saying find time taken to reach maximum height. So obviously we're going to make T the subject of the formula. If we make T the subject of the formula, the equation will look like this. V minus U over A. So final velocity minus initial velocity over A, which is the acceleration. So obviously, what do we know? We know that whenever an object is going upwards, it is decelerating. And at the highest point, let me write this down. At the highest point, V is equal to 0. Okay, the final velocity. So we are now plugging in our values now. So T is equal to, at the highest point, what? We don't know what the highest point is, but we know that at that highest point, V will be equal to 0. So V is equal to 0 minus the initial velocity which we've been given, which is U is equal to 29.4 meters per second. If you don't know where I get this, it means you are not paying attention, but I'll let that slide. Okay, I'll read the question again. The stone is thrown vertically upwards with an initial velocity of 29.4 meters per second from the top of a tower. So a person is on top of a tower, then he throws a stone vertically upwards with an initial velocity of 29.4 meters per second. So which means that's U. That's our initial velocity. And that's where I got this 29.4 meters per second. Okay, so T is equal to V minus U over A. According to our substitution, we have made T the subject of the formula from the equation A is equal to V minus U over T. Then V is equal to 0 at the highest point. Then our U is 29.4 over the object is going upwards. A is equal to negative G. Negative g is negative 10 meters per second. Okay. Don't worry about for the moment, don't worry about the units of measurement, all right? I'm just plugging in the values. So because I don't want you to get confused, I will just plug in the units at the end of the question. Okay. So now we have 0 minus 29.4 over negative 10. Obviously, this is simplified as 29, negative 29.4 over negative 10.0, obviously. Then negative divided by negative leads to a positive. So we can see that t is equal to 2.94 watt seconds. You can just know that we are calculating time, and time is measured in seconds. Then you plug in your unit at the end of the question. So the time it will take to reach that highest point is going to be 29.4. So I want you to keep this value, okay? Keep it close, because this 29, the 2.94 seconds, because we need it to tackle the second question. Okay, so the second question goes like this: the time taken to reach the maximum height we found it, which is what? Which is 29.4 seconds, which is 2.94 seconds. I'm sorry. Then the second question is going like this: the total time which elapses before it reaches the ground. Okay, that's a long question. We're going to do loads of calculation. Okay, so I want you to take note now. This person is on the top of what? Of a tower. He's not on the ground. He's on the top of the tower. Then he throws the stone upwards, right? And it takes 2.94 seconds to reach the highest point. Then it starts returning to the ground. Okay, so right now we want to calculate the total time it will take, not to get back to the position of the thrower. No, who is the thrower is 34.3 meters. 34.3 meters up a tower. All right. So obviously the stone will take less time to reach him than it will take to reach the ground. Okay. But we want the total time now. So how do we do that? How do we do that? Okay, so let's start looking at our equations. What do we want? We want total time. We want the total time it will take for the stone to reach the ground. Okay, so take note of this. Take note of this. We are not, okay, we're going to be using this equation. Let me write the equation down. X is equal to ut plus half at squared. Okay, so we will need to calculate the height the stone reached when it was thrown from 34.3 meters above ground. Toda kuziva kuti kubva patawa iroro kusvika pamusoro pahighest point yakasvika ingatravela mameters mangani, a displacement of how much. Okay, so how do we figure that out? We use this equation. So because t, we already know that to reach the highest point, t is equal to, that's why I told you to keep this value close to you, 2.4 seconds. T is equal to 2.94 seconds to reach the highest position. Okay, so we want to know how. Okay, so x is equal to what? 29.4, the initial velocity times this time 2.94 plus half of what? Plus half of a, which was negative 10 meters per second. Why is it negative? Because the object is going upwards. Negative 10 times t squared. What is t squared? 2.94 squared. Okay, don't get lost here. So the question wants us to calculate the total time, but before we reach that position, we need to know how far did the stone travel above ground. Okay, so let me illustrate this with an example. So this is a tower which is 34 34.3 meters above ground. Stay with me here. I'm doing this illustration for further clarity. Okay. So the person is here, throws a stone which reaches its highest position, in 2.94 seconds. But so the second question now wants us to calculate how long this stone will take to reach the ground. This is the ground. But for us to know that, we need to know how far the stone traveled from the position of the thrower, who was 34.3 meters above ground, to the highest position. So that's why now we are using this equation, using this time. This time is to travel from here to here. Using this time, we're using this equation, which is x is equal to ut plus half at squared, to know how far the stone traveled above the position of the thrower. Okay, so let me take my calculator now and plug in those values. Okay, I hope you've done your calculations. So if you pass these values in a calculator, so take note there's a negative here. Why is there negative? The stone was traveling upwards. Okay, so acceleration will be negative. So negative 10, half of negative 10, which is 5 times 2.94 squared, will give us 43.2, rounded to the nearest whole number. Rounded to the nearest one decimal place. Then 29.4 times 2.94, which is ut, will give us 86.4, rounded off to the nearest one decimal place. So 86.4 minus 43.2 will obviously give us 43.2 meters. Okay, so that's the height the stone traveled from the thrower. So if you're not paying keen attention here, you might lose us. Okay, so from this position to the highest position, the stone traveled 43.2 meters, right? But the person was not on the ground, was above a tower, which is 34.3 meters above ground. So the question, what is the question saying? Let's get back to the question. The question wants us to the total time which elapses before the stone, it referring to the stone, reaches the ground. Okay, the total time which elapses before it reaches the ground, it referring to the stone. Okay, so which is now an easy question. Let me take a clean bond paper, which is now easy, provided if we use this equation. If we use this equation, this will be very, very, very easy. Okay, so if we use this equation 4, if we use equation 4, which says x is equal to ut plus half at squared. So what are we looking for? The question wants us to find t. So we are going to make t the subject of the formula in this equation. Okay, so I've already said this, that you should know how to make stuff the subject of the formula. Okay, so okay, I'll just do it so that those who have a weakness in this concept might learn something. Okay, so we want to find t. Obviously, we're going to make this term travel here. So x, and it will become a negative, right? So x minus ut. X minus, let me cancel here. X minus ut is equal to half of at squared. Is equal to half of at squared. Okay, so without wasting further time, let's plug in the values. Okay, we know that x is what? Okay, I want you to get this. X is now the addition because you want to know the total time for the object to reach the ground. So x, the displacement here is now the addition of the height from the tower to the ground plus the height from up the tower to the highest point. Okay, so x is now what? X is now equal to 43.2 plus 34.3. That's now x. This will obviously lead to 77.5. So x is now equal to 77.5 meters. That's our new x displacement, right? So let's go back to our original calculation now. So where is our original calculation? Okay, let's just use this equation. Okay, yeah, this is the question I was working on, paper I was working on. Okay, so our new x is 77. X is now equal to 77.5 minus u, right? Minus u. So I want you to take note of this again now. So in physics, you're gonna have to strain your brain a little bit. Okay, so I want you to take note of this. So we are now calculating the time it will take from here to here. So when the stone reaches the ground, that will be the final velocity. Then when it starts from rest now, when it's going up, this is the final velocity. But when it starts going down, this is now the initial. When it's going up, it's the final. It's V. But when it's starting here and falling to the ground, this is now the initial. So we can see that the initial here is what? Is 0. The initial is 0. So initial velocity when it's starting from the top is 0. So 0 times what? Times t. T is the variable we're looking for, right? So we're going to put t here. Is equal to what? It's equal to half at squared. Half of what? Of 10. So 10 is now positive. Why is it positive? Because the object is falling to the ground. We want to calculate the time it will take to reach the ground. So the object is falling from the ground. So t is positive when an object is falling, because it will be gaining in acceleration. It will be gaining in velocity, t squared. Okay, so half of 10 is obviously 5. So 0 times t here is going to be what? Is going to be 0. So we're going to be left with 77.5 is equal to half of 10, which is 5. Which is 5 here. So half of 10, which is 5, t squared. Okay, so divided by 5, divided by 5. 77 divided by 5. So 77.5 divided by 5 will be equal to 15.5 equal to t squared. So if we put a square root sign here to remove that squared, so the square root of 15.5 is equal to t, right? We are now seeing that therefore, what repeats the question, right? Therefore t is equal to square root of 15.5, right? The square root of 15.5, therefore t is equal to 3.937. So t is equal to 3.937. If you round it to the nearest 2 decimal places, t is equal to what? 3. T is now equal to 3. Oh God, let me write it here. So t is now equal to 3.94 seconds. Don't leave the unit. T is now equal to 3.94 seconds. That's the total time it will take from the highest point to reach to the ground. So I want you to get something here. So if you think that it will take obviously less time when the object is falling than when it's going up. Why is that? Because when it's falling, it's increasing in velocity. Acceleration is positive. When it's going up, it's decreasing in velocity. acceleration is negative. So that's it. So the next tutorial is going to be questions only. We are not going to be talking about equations. We're going to be doing pure questions on kinematics. Probably it will be the last tutorial we'll go through. Okay, so when we go through that last tutorial, I hope everyone will be now equipped to tackle any kinematics problem, whether it will be vertical or whether it will be horizontal. Okay, so thank you very much for staying with us, and subscribe. We'll have to stay with you, so subscribe.